Today we will discuss about the change of variable. Change of variable. Sometimes we are not able to solve the problems directly, so we need a change of variables. So we change the dependent variable into independent variable or independent variable into the another independent variable. So we start with the first to change independent variable. Into the dependent variable. So here we change the independent variable to dependent variable. So suppose y is equal to function of x. So we are talking about the single independent variable. Single independent variable, that means x here. So y work as a dependent variable. So this y we write down as dependent variable and x work as a independent variable. Okay. So we have a derivative. So we always do the derivative of dependent variable with respect to the independent variable. So the derivative of dependent variable with respect to independent variable. So we write down the derivative of above function y equal to fx. So the derivative of this function can be denoted as dy upon dx. Okay, so this is the derivative. Now we write dy upon dx is equal to. So when first thing is that we take as dx upon dy raised to the power -1. So we just change the independent variable into the form of the dependent variable. So we can write dy upon dx into the form of dx upon dy raised to the power -1. Now, again, we take as a d square y upon dx square. So when we obtain the second derivative, so that means this can be written as d upon dx into dy upon dx. So now we write down as d upon dx. The value of dy upon dx we obtained as dx upon dy raised to the power -1. Okay. So now when we differentiate dx upon dy raised to the power -1 with respect to x, so we see that means here outside the independent variable is x, but inside is independent variable is y. So we cannot differentiate directly. So we what we will do? So first we differentiate this as dx upon dy raised to the power -2 into differentiation d upon dx of dx upon dy. So this we can write down as -1 dx upon dy raised to the power -2. So here outside the independent is x, inside independent is y. So we cannot differentiate directly. So we apply the chain rule. So this can be written as d upon dx can be written as d upon dy into dx upon dy and dy upon dx. So this dA upon dx we can denote it as we write down here. So this d upon dx we can write down as d upon dy into dy upon dx. Now we can differentiate easily. So that means here is the function independent variable y. So also here is also y. So we write down this as -1 and dx upon dy raised to the power -2, and differentiation of this is d square x upon dy square into dy upon dx. So what is the value of dy upon dx? So the value of dy upon dx is equal to dx upon dy raised to the power -1. So now we write down this as dx upon dy raised to the power -3 into d square x upon dy square. So this is the value of d2y over dx square. So when we change the independent variable x to dependent variable y, we put the value of d2y over dx square as -1 dx upon dy raised to the power -3, or d2y over d2x over d2y square. Now again, when we obtained a dqy upon dxq, means third derivative. So this is also we can write down as d over dx into d2y over dx square. So this equal to d over dx, and the value of d2y over dx square is -1 dx upon dy raised to the power -3 into d2x over dy square. So here we use the product rule. So that means this can be written as -1 into differentiation of first. So differentiation of first you can write down as -3 dx upon dy raised to the power -4 into differentiation of dx upon dy into second function we write down as same, plus first function we write down as same, dx upon dy raised to the power -3 into differentiation of this. So d upon dx into d square x upon dy square. Okay. So we write down as minus minus plus, so +3 dx upon dy raised to the power -4. And same thing we do outside the independent variable is x, inside independent variable is y, so we cannot differentiate directly. So we write down this as d upon dy into dx upon dy into dy upon dx into d2x upon dy square minus, so this negative sign we taken here, minus dx upon dy raised to the power -3 into same thing we do here also. So we write down this as d upon dy into d square x upon dy square into dy upon dx. So this we write down as 3 dx upon dy raised to the power -4, and differentiation of this is d square x upon dy square into the value of dy upon dx we put here. So we write down as dx upon dy raised to the power -1 into d square x upon dy square minus, we write down as dx upon dy raised to the power -3 into dqx upon dyq into the value of dy upon dx we also write here dx upon dy raised to the power minus. So finally we write as dqy upon dxq is equal to 3. So here is power 4 and one power is this. So we write down the power of dx upon dy is -5, and one power of d square x upon dy square here, and one is this. So we write down as d square x upon dy square to the whole square minus. So power 3 is here and 1 is this. So we write down as dx upon dy raised to the power minus 4 into dqx upon dyq. So this is the third derivative. So similarly, we can calculate fourth derivative, fifth derivative as required, and we change the independent variable x to dependent variable y. Okay, so second, we take as to change independent variable into another independent variable. Okay, so in this case, we change independent variable into form of another independent variable. So we write down as well, let y be a function of x and x is a function of t. So then we uh, write down as dy upon dx as, so dy by dt and dt upon dx. So this can be written as dy by dt and dt upon dx. So here also dt upon dx can be written as dx upon dt raised to the power minus 1. So we write down this as in short. So d upon dx is equal to dx upon dt raised to the power minus 1 into d upon dt. So when we operate any dependent variables. Okay, so similarly, you can calculate for second derivative or third derivative. Okay, so now we take one problem related to that. So we have a question, change the independent variable from x to y in the equation given as the rho is equal to 1 plus dy upon dx to the whole square whole to the power 3 by 2 upon d2y over dx square. Okay, so here we see that the independent variable x, but now we change into the dependent variable y. X change to y. So we write down as given as rho is equal to 1 plus dy upon dx to the whole square whole to the power 3 by 2 upon d2y over dx. So we directly put the value. So put the value of dy upon dx. So what is the value of dy upon dx? The value of dy upon dx is dx upon dy raised to the power minus 1 and the value of d2y over dx square. What is the value of d2y over dx square? The value of d2y over dx square is minus 1 dx upon dy. So we write down as minus dx upon dy raised to the power minus 3 into d square x upon dy square. So we see that rho is equal to 1 plus the value of dy upon dx. So we put as a dx upon dy raised to the power minus 1. But power is 2. So this directly we write down as power minus 2. Whole to the power 3 by 2 upon the value of d2y over dx square we write down as minus dx upon dy raised to the power minus 3 into d square x upon dy square. This equal to, we simplify this as, so we can write down as 1 plus 1 upon dx upon dy to the whole square, whole to the power 3 by 2 upon minus dx upon dy raised to the power minus 3 d2x upon dy square. So in numerator, we will take the LCM as dx upon dy to the whole square. So this can be written as dx upon dy to the whole square plus 1 and whole to the power 3 by 2 upon. So when we write the denominator, so the power will be dx upon dy to the whole square or whole to the power 3 by 2, because the whole power is 3 by 2. Into, we write down directly the denominator of this also. So this can be written as dx upon dy raised to the power minus 3 into d square x upon dy square. So here this 2 to 2 cancelled. So this we can write down as 1 plus dx upon dy to the whole square and whole to the power 3 by 2 upon. So we see that the power of dx upon dy in first term is 3 and here is minus 3. So the power will be 0 of dx upon dy. So we can write down this as plus 3 and minus 3. And the second term is d square x upon dy square. Okay, so power is 0. So something power 0 means 1. So we write down as 1 plus dx upon dy raised to the power 2 and whole raised to the power 3 by 2 upon d square x upon dy square. So this is our answer. So here we change the independent variable to dependent variable y. Okay, so hope you understand. Now, second problem we take as we change the one independent variable into the another independent variable. So here we solve some differential equations. Okay, so question is, show that uh, by substitution x is equal to e raised to the power z, the equation x square d2y over dx square plus x dy upon dx plus y is equal to 0 changes into the equation, d square y upon dz square plus y is equal to 0. So this is our question. Here we use the substitution, that means x equal to e raised to the power z. So now in this problem, we see that our independent variable is x, but we change this independent variable into the form of the z by using this substitution. Okay, so we do the solution. So given that x is equal to e raised to the power z. Okay, so this is the relation. We can say that in x and z. So given that x equal to e raised to the power z, now when we differentiate this with respect to z, so we can calculate dx upon dz. So what is the dx upon dz? So e raised to the power z. Now, when we write down this as dz upon dx. So dz upon dx means e raised to the power z raised to the power minus 1 gives us e raised to the power minus z. Or you can write down as, if x equal to e raised to the power z, so taking log both sides, so this gives us z is equal to log x, or when we differentiate with respect to x, so this gives us 1 upon x. So dz upon dx is equal to 1 upon x. Now, We move to the given differential equation. So this is our differential equation. So first we obtain the value of dy upon dx, then d2y over dx square. So now first we start with the dy upon dx. So this equal to, so when we change independent variable x to z, so we can write down by using the rule. So dy by dz into dz upon dx. So this can be written as dy by dz into dz upon dx. So we have calculated e raised to the power minus z. So this is the value of dy upon dx. Again, we calculate d2y over dx square. So this equal to, we write down same d over dx into dy by dx. So this equal to d over dx into dy by dz into e raised to the power minus z. So we see that outside the independent is x, but inside the independent variable is z. So we use the root. So this can be written as d upon dz into dy by dz into e raised to the power minus z into dz upon dx. Now we differentiate this with respect to z. So we see that there are two functions of z. So we use a product rule. So that means we write down the first function into differentiation of second with respect to z plus differentiation of first d2y over dz square into same second function same as it is into dz upon dx. So what is the value of dz upon dx? The value of dz upon dx is e raised to the power minus z. So we substitute the value. Now we write down this as, here is e raised to the power minus z, but e raised to the power minus z. So this can be written as e raised to the power minus 2z into dy by dz plus same as e raised to the power minus 2z d2y over dz square. Okay, so this is the value of d2y over dx square. Now putting these value in this equation. So this equation you can assume that 1. So we write down as putting the values of dy upon dx and d2y over dx square in equation 1. So we have x square into d2y over dx square. So this is e raised to the power minus 2z into dy upon dz plus e raised to the power minus 2z d2y over dz square plus x dy upon dx. So dy by dz into e raised to the power minus z plus y is equal to 0. So we also change the value of x. So we put x equal to e raised to the power minus z. So this can be written as e raised to the power minus 2z in place of x square. So minus e raised to this substitution is e raised to the power z. Sorry. So this is e raised to the power z. So e raised to the power z. So this can be written e raised to the power minus plus e raised to the power minus 2z d2y over dz square or plus e raised to the power z dy upon dz into e raised to the power minus z plus y is equal to 0. So when we multiply e raised to the power 2z into inside the bracket, so this gives us e raised to the power 2z or e raised to the power minus 2z, so e raised to the power 0, this gives us 1. So we write directly dy by dz plus d square y upon dz square plus for this term also dy upon dz plus y equal to 0. So we write plus y is equal to 0. So this dy upon dz to dy upon dz cancelled. So this gives us d2y over dz square plus y equal to 0. So this is the required equation. Okay, so we have proved. Thank you.